Yes, class. So in the last class, we started with this. We couldn't complete this question. Let us quickly complete this. And as we discussed, lots of questions we have to practice. Yesterday also, many questions we had seen, but today more questions we'll see. All right. So 3-point charges. This question we discussed that 1 coulomb of charge is present, 3 coulomb of charge, and 2 coulomb, 1, 2, and 3. These are placed 1 coulomb, 2 coulomb, and 3 coulomb. These are placed at the corners of an equilateral triangle of side 1 meter. Calculate the work required to move these charges to the corners of a smaller equilateral triangle of side 0.5 meters. So see, when we are talking about the initial potential energy of the system. So initially it is K. Let's take K already common. So it will be Q1 into Q2 by R12 plus Q2 into Q3 by R23. And last combination will be Q1 into Q3 by R13. Understood? What is the general formula, class? General formula of energy is K Q1 Q2 divided by R. So 1 interaction, 2 interaction, 3 interactions, all we have written. Now we just have to substitute in the values. For K, it's 9 into 10 to the power 9. 1 into 2. Separation is 1. This is also 1 meter. This is also 1 meter. I'll give you sufficient time to note down the question and the solution. Just understand and listen carefully. And also one thing, today's class duration is 2 hours. Yesterday, someone had to leave, so I ended the class earlier. Today's class is of 2 hours duration, so that we can complete a lot of portion also of the first book. Though magnetics we have done, but let us see how much we are able to do today. So 1 into 2 divided by 1 plus 1 into, this will be 2 into 3 divided by 1 plus 3 into 1 divided by 1. So this is 11. So that becomes 9.9 into 10 to the power 10 joules, right? This is the initial potential energy of the system. Then when we are talking about the final potential energy of the system. So U final, this is K. Q1, Q2, same thing, but new separation. Again, plus Q, let's take K common. So we can write this only Q2, Q3 by, this is R12, but dash. So that 0.5 we can substitute. The smaller one. This is Q1 into Q3 by R13 dash. So this is 9 into 10 to the power 9. This will be, now the new one was 0.5. One we have done, all this entire, this is 0.5. So this is 0.5 plus this is 2 into 3 by 0.5 plus 3 into 1 by 0.5. So this is equal to 9 into 10 to the power 9. Okay, so that was 11. So 11 into 2, this will become 22. So this is equal to 9.8 into 10 to the power 10 joules. Now, when we have to calculate the work done, so work done will always be final energy minus initial energy. Final energy is this. Let's take 10 to the power 10 common. So 19.8 minus, that was 9.9. And common is into 10 to the power 8 joules. No, 10 to the power 10 joules. So this is your final answer. How much this will be? This will also be, this is half of it. So answer will be 9.9 into 10 to the power 10 joules. Write down the question, those who weren't there yesterday. Those who have written the question, start with the solution. I'll be sharing some questions on capacitor also, because second chapter questions we didn't do much. So I am discussing, let me tell other students who were not attending the revision classes, we will be discussing in chapter 1, chapter 2, chapter 3, chapter 4 till magnetics. Though magnetics we have done, but a thorough complete revision of all of these. Yes, class. This says that n spherical droplets, each of radius r, have been charged to have a potential V each. If all these droplets were to coalesce to form a single large drop, what would be the potential of large drop? One thing that I always tell you all, whenever drops and these are given, keep in mind that volume could be used. So in the bracket, it's written, it is given that the capacitance of a sphere of radius x equals, all right, 4 pi epsilon naught k x. See, what is the potential of each drop? Potential of each drop when you are calculating, that's V. When we are talking about the capacitance of each droplet, if we are talking about the capacitance of each droplet, then that is C, which is mentioned in the question, capacitance of the sphere X. This is equal to this. So this is equal to 4 pi epsilon naught k r. Clear? So what will be the charge on each? What will be the charge? CV.
Yes.
Charge will be CV. So charge on each droplet will be Q, which is equal to C into V. So multiply this term, that is 4 pi epsilon naught kr into this V, correct? So what is the total? Let's say n number of droplets are present. If we are calculating, because n is, it's already given in the question, n spherical droplets. So we cannot leave it like this. Understood? In this question, it is already mentioned n spherical droplets, each of radius r, this is present. So for n droplets, this is given as n into 4 pi epsilon naught k r into V. Now class, now comes the part which I was telling you, whenever you have this collision, always have the concept of volume in your mind. This is a trick, this is a rule, learn it, whatever ways you have to remember it. Keep in mind that you have to write the all the volume transferring, you have to mention volume transfer that occurs, because volume is being mentioned. Because if some things, if even they both are coalescing and forming bigger one, so it means one is being present here, one is being present, so it means volume will remain the same. So again, you will use 4 by 3 pi capital R cube, this is equal to n number of small into 4 by 3 pi small r cube. 4 pi gets cancelled, r is equal to n to the power 1 by 3 small r. This is the relation of the radius, and these types of relations are always used. Here it's n, usually this number is given as 8, where we write r is equal to 2r. Most commonly it is given as 8. A number will be given that you will be able to calculate, not a difficult question will be mentioned. Anyways, so new potential, yes, so new
Ma'am,
capacitance of the large drop would be, yes. Someone
I'm
is
like you have to
asking.
substitute this R value.
Yes, correct. Very good. Very good, Shaviz. We'll substitute the R value because we have to find out capacitance for the large drop, right? So when we are finding out the capacitance for the large drop, this will be 4 pi epsilon naught k into capital R. So you will substitute the value of R which you have obtained. This will be 4 pi epsilon naught k n to the power 1 by 3 into small r. So what will be the potential of the large drop? New charge by new capacitance. What is the new charge? 4 pi epsilon naught k small r nv. We had already calculated it and kept it. For the new capacitance, it is 4 pi epsilon naught k n to the power 1 by 3 r. So what are we left with? 4 by 3 epsilon naught, 4 by 3 epsilon naught, k cancelled. Small r would be cancelled. 1 minus, this will be 1 minus 1 by 3. So 2 by 3. So answer is n to the power 2 by 3 and this potential will be remaining. This is it and this is of the large straw. It's a good question. Mark it as important. Write it.
You can just scroll. Then
See, this says between the plates of a parallel plate capacitor of area A, a copper plate sits on a dielectric slab of K is equal to 2. Dielectric constant is given as 2 in this figure. Find the equivalent capacitance of the arrangement. See, this is C1, this is C2, this is C3. C1, C2, C3. So when we are talking about C1 individually, first you have to calculate, because see, this is a series combination. You can already figure it out. How? I have told you when we were studying this topic, capacitor, I told you when the distance is being divided, distance is getting divided and area is not getting divided. That shows that's a series combination. And see, area of all the plates is same. If the area of this plate is A, this is A, this is A, this is A, all the net area is A already. So when we're talking about C1 specifically, so this will be K, that is 2 epsilon naught A by D by 3. So this is equal to 6 epsilon naught A by D, correct? 3 into 2, 6. When we are talking about C2, we do not know K, right? Copper, because only for copper we know. Copper plate, a parallel capacitor area A. This sits, yeah, for the second plate, for the copper one, copper plate sits on a dielectric slab. So this was 2, but for copper it wasn't. Let's put it as K only. K epsilon naught A by D by 3. This will be equal to 3 into K into epsilon naught into A by D. Acha, one more thing, class. K is equal to, K will be infinite, no? For, copper is a metal. One thing, see, copper is a metal. So K will be infinite. So if K is infinite, infinity, that is capacitance will be simply 0. Let's keep it like this, because reciprocal we have to take, and for infinity reciprocals change. So let's keep it like this, but remember this, when we'll calculate the final one, this will be reciprocated, so that time this term will be 0. Okay, when we are talking about C3, C3 is epsilon naught A D by 3. So this is 3 epsilon naught A by D, right? So when we are calculating the, now, yes, this I was telling you, when you are calculating the net capacitance, when we are calculating the net capacitance, so 1 by C equivalent will be 1 by C1 plus 1 by C2 plus 1 by C3. So when you will substitute this, 1 by C1 will be D by 6 epsilon naught A, plus this will be, second one will be 3 D by 3K epsilon naught A, plus this will be D by 3 epsilon naught A. So since this is infinite, 1 by infinite will be 0. We'll say this entire term is 0. Hence, you have the answer as 2D. No, this will be multiplied by 2. Right? We'll multiply and divide it by 2. So 2D plus this becomes 3D divided by 6 epsilon naught A. This will be D by 2 epsilon naught A. Is this my final answer, class? Yes or no?
Yes, ma'am.
No. Look, this is the mistake that you will make in the exam. Be careful with this. This is 1 by C equivalent. C equivalent will be 2 epsilon naught A by D. So whenever you're handling questions of capacitors, be careful with this. Yes, Austin, good, reciprocal. How were your pre-boards, class? Pre-boards must be over by now. Many of you were not even attending the classes. Shahid was very regular with the classes. Deborah was also there. Harif was there in the classes. Pfizer came yesterday, but most of you weren't regular. Austin, I am seeing after a long time. Chavez was also not coming. So I hope by now your pre-boards are over. How did you do in your pre-board? Send me your question papers and just give me a feedback of your exam in just 1 to 2 lines in the chat column right now, so I'll have an idea. And if any part you want me to discuss, let me know that also, because these are now revision classes only. Not about the marks I'm asking. If your exams are just over, I don't think so. You will be receiving the marks right now only. Your feedback, how did you find? What are the difficulties you face? I'm just asking about physics. I'm having Viva. Pre-boards will start from 23rd Jan. Okay, that's well. You have time then. Those who have given their pre-boards, I want your feedback, not your marks. Marks will be coming later. First, your anything that you face difficulty in derivations, in your formula based questions, in the numericals, anything, or the paper was fine, difficult, you completed it on time, anything. I just want the feedback by all of you who have given it. Plate A of a parallel plate capacitor is connected to a spring of force constant K and can move while the plate B is fixed. This is fixed, this can move. The arrangement is held between two rigid support as shown. If a charge plus Q is placed on a plate A and minus Q here, this is plus Q here and minus Q here, by how much does the spring elongate? See, for SHM conditions you must have heard. As you know, the two plates carry equal and opposite charges. So if they are carrying equal and opposite charges, they will be attracting each other. And if they attract each other, see, and if they are attracting each other, then it will, see, spring elongates by a length, right? If the spring is elongating by a length, so condition of SHM is fulfilled. That is, F is equal to minus KL. This you must have done it in your class 11. Now capacitance is equal to epsilon naught A by X, whatever X is the elongation. Now look, energy is stored in a capacitor. When we are talking about energy that is stored in a capacitor, that's Q square by 2C. Right? Let's put the value of C here. That becomes Q square by 2. And instead of capacitance, we have epsilon naught A by X. This is the total energy. So X Q square by 2 epsilon naught A. Now, electrostatic force is a conservative force. This is one very helpful, one different thing that will help you to answer your exams. F is equal to minus du over dx. Because it's a conservative force, we write it like this. It's a formula of it. This is energy. So d over dx and u is q square x by 2 epsilon naught a. This is equal to minus q square by 2 epsilon naught a. So minus k into L is equal to minus q square by 2 epsilon naught a. So from here, L was missing. L will be equal to q square, minus minus sign will be cancelled. Q square by 2 epsilon naught K. This will be the final length which is asking. It was asking, how much does the spring elongate? So the spring will elongate by this much amount. Write it down.
Ma'am,
Yes.
could you just explain this again?
See, if the spring is moving, you must have heard of the condition of the movement of spring, that is the conditions of SHM. When the spring of force constant, spring factor, spring constant is given, F is equal to minus KL is the formula. Minus sign just shows that direction of forces towards the displacement position, the direction of
It is
displacement.
the displacement.
Displacement is in the spring that is occurring because of the charge, because this is charged. So due to the charge, this will be coiling. So this will be very close to each other like this. So from the mean position, some amount of displacement must have occurred, which we are writing it as L. That is F is equal to minus KL, this one. Clear? In spring mass system, in pendulum systems, you already have this constant, which is the spring factor. So whenever coiling occurs due to any external force. Now, what is the external force? External force is this electrostatic force. So capacitance is there. Now we have substituted in the values of capacitance in this formula of energy. For conservative forces, this is the formula between the relation of force and energy. And when you write it, from here you equate both these forces, you get the value of the length. Clear?
So X is the distance between two capacitors.
Yes. See, X is the Yes, x is this distance between plate A and plate B.
Okay.
C class, in the circuit shown in this figure, heat produced in 5 ohm resistor due to the current flowing through it is 10 calorie per second. Find the heat produced in 4 ohm resistor. So see, heat produced per second in 5 ohm resistor, according to the question that is given. So that is 10 calorie per second. So we'll convert it into joules, which is 4.2. That becomes 42 joules per second, right? Now, power is equal to V square by R. When we are calculating potential difference, it will be under root P into R, correct? Right? Now see, if we are calculating between points A and B, that is given according to the question. So when you substitute in the values, this will be under root 42 into 5. So that is under root 210 volt. Now keep voltage aside. Current through 4 ohm resistor, let's calculate. Current through 4. Yes?
Power is in 5 ohm resistor, right?
Yes, 5 we are choosing of the resistor. Between A and B we are calculating, and for the rest of it we are calculating separately. This is just for this arm. So in this arm we only have this 5 ohm resistor. Okay, and now we are calculating the current through this, then we'll use this. Net current we have to find out, because it is showing the heat is produced in the 5 ohm resistor only.
And
So
like they
we
are telling
cannot.
to find power.
Yes.
Like heat means they are telling to find power.
What are you saying?
And like heat means they are telling to find power.
See, when it is giving 10 calorie per second, this is the power due to the current flowing in. It is 10 calorie per second. This is saying the heat produced is 5 ohm per resistor. So between A point and between this B point lies this 5 ohm resistor. So we have calculated the potential through this. Now one thing, if potential is root
Okay.
10, you're asking something from here. You are
No,
asking this only, no, about the 5 ohm.
understood.
Yeah. So 5 ohm we are only including, we are not including 4 or 6 ohm because power was given through this 5 ohm resistor only. So we have root 10, root 210. So it means if root 210 is the voltage here, same voltage will be there in the parallel combination, because ultimately we want to find out heat produced through this. This is our question, right? So at least we have the voltage. So let us calculate the current through this 4 ohm resistor. So when you are calculating the current, that will be under root 410, and net current you will take, that is 4 plus 6, because current will be same in both of them. That will be by 10. Leave it like this much amperes. When you are calculating the heat produced per second, when you will be calculating the heat produced per second in the 4 ohm resistor. Now see, this heat will be equal to I square R. Now I square will be root 210 by 10 we had calculated, I square into the resistance. Which resistor we are calculating? 4 ohm. So we will multiply it by 4 joules per second. This will be 210. This will become 100 into 4. And see, this was joules per second. Let us calculate the final answer in calories, because it was given in calories. So divided by 4.2. So 4.2, this is double of it. So 2. So 2 only will be left. 2 calorie per second. That's it, how you have to calculate. It's also a very good question. Mark it important. Write it down. Then we'll take a break of 2 minutes because your class is till 8:30 today and no other class is there. Write it. Any doubts? Okay, class, after writing this, you can take a break of 2 to 3 minutes. Then we'll practice rest of the questions. Because you've been studying since 6:30, so you can take a break of 2 to 3 minutes.